Alright, yes, I am not here, but I would like you to take a couple seconds, try these warm-up problems out. Problems like numbers 2 and 4, you'll definitely probably see something like this on your test coming up next week. So do give them a shot. Take a couple seconds here, press pause. When you're ready, press play again, and check see how you did. Now, hopefully you did press pause and wait for the answers, but if you work through number 1, so f of 9, what we did yesterday, plugging in 9 for x, throw it in here, so f of 9 equals 2 times 9 plus the square root of 9. 2 times 9 gives 18, square root of 9 is 9. F of 9 comes out to be 21. Number 2, simplify. Again, you might see something like this, what we talked about on Monday. Take it step by step, working through each letter at a time. So we start with A to the negative second over A, and move the negative exponents down below. Then we look at B to the third, B to the negative third, move the negative exponent up top. And then C to the second over C to the 0 power. We don't need anything to the 0 power is going to be 1. This would simplify out to be B to the 6th, C to the 2nd, over A to the 3rd. Now, number 3. Anytime you see this setup right here, hopefully you're thinking we need to distribute, and you'd be correct. Multiply that 3 throughout, giving us 17 equals 3x minus 15 plus 8. From here now I can simplify common terms here on my right side, giving me 17 equals 3x minus 7. Solving equations here, add the 7 to the other side, give me 24 equals 3x, and from there I get a value of x equals 8. Number 4, classify the numbers. Has been a while since we talked about this, but you do need to know. Hopefully look here, it is a decimal. In decimal it can be turned into a fraction, should be a rational number. And then everything we know of right now is still real. So rational and real. Number 5, key here, number 5 is there's no parentheses. So you take the 7 squared first, tack on the negative, you get negative 49. So again, hopefully you did those problems, hopefully you did pretty well. You probably see problems like number 1, 2, 4, and possibly 5, something like that on our test we might be seeing next week. Alright, starting off with what we're talking about today though. We're going to do an introduction to parent functions. Alright, today's going to be just a brief introduction. Section 1.9, just giving you the basic understanding of what graphs and functions are. And again, as we continue to progress through Algebra 2, doing a lot of different graphing, a lot of different functions, as long as you have the understanding of what a graph should look like, it helps the understanding of when you actually do the work on the graphs. So again, introduction to parent functions, section 1.9. Vocabulary here, the parent function. The parent function is essentially the simplest function with defining characteristics of the family, and that's really what we're going to focus on today. We're just going to focus on, hey, whenever you see a specific function, what are the characteristics or what's the type of graph we're going to make. Functions in the same family are transformations of their parent function. Essentially, every graph can be transformed. For some of you, maybe higher order learners, you can maybe focus a little bit more on the transformations and how you can transform. But again, we really just want to focus on what's the simplest function or what's this really graph going to really look like here. Parent functions, these are the ones that we need to know. So as I look through here, these are just some of the base ones we're going to continue or to start off talking about. A linear, this is something you should all know by now. Being in Algebra 1, a line graph. So a line graph, this is just one of the forms it could take. But it has a slope typically. F of x equals x. The key here is there's no exponent, or the exponent's invisible 1. Okay, so a linear function would have the invisible exponent f of x equals x. And that can go for any range of things. You know, I could have f of x equals 2x. That's still going to be a line linear function. Okay, next one, we had this in a problem yesterday, but it is a quadratic. Alright, quadratic makes what would be a U-type graph. Okay, it makes a U-type graph. And it's a quadratic because it has a quadratic term, which is x squared. And the actual technical name for that graph would be a parabola. And again, it makes a U-shaped graph, parabola. We will do a whole chapter on quadratics and parabolas later on. But yeah, there's the idea of what a quadratic, anything with a term of x squared would make a quadratic. So I could still do, you know, f of x equals x squared plus 3. And that'd be a quadratic term because I have that x squared term. Cubic. Cubic would be just like you think of, back in geometry, something cubed. Its volume, okay, it has an exponent of 3. That is cubed. All right, cube term, again, kind of goes up and over and then down and out. We had an example of a cubic term in our functions the other day. If you look back in section 1.6, relations and functions, we had an example of a cubic function there. Another example, again, would be, f of x equals 2x cubed minus 2. Okay, that cube term tells me it's going to be a cubic function. Then the last one we're going to focus on today is the square root function. Okay, f of x equals the square root of x. Now, as you look at this graph, you see the parent function starts at 0. Now, take a second to think about why is the graph not on the left side of the coordinate plane. Now, hopefully I paused long enough for you to think about it, but the reason it's not on the left side is because you can't have a negative underneath the radical. Okay, that gets us into what would be imaginary numbers, which again will be a future topic in Algebra 2, but you can never have a negative underneath that radical. So we start at 0 because anything on the left side of that doesn't exist. So again, the lowest value you could have on the square root function in this example would be 0, and then it's all the positive numbers up to the right. And again, another example I could have there, was f of x equals the square root of x plus 2. Okay. Again, anything with a radical would have a square root type function there and follow kind of the same idea. Now, if you look down at the bottom, you look at a parent function here. X has the power of 3. So if you look right here, the basic graph type of idea would be a cubic graph. And if you look, should be kind of a parent function here. And look down below, we can compare this graph, x cubed minus 1, to the one down below. And notice that it is a vertical translation 1 unit down. All right, so stop and think about why there might be that vertical translation 1 unit down compared to when we had that base parent function up here of just f of x equals x cubed. Now, hopefully some of you might have noticed, but the reason it's a translation 1 unit down is that constant term right there. So x cubed minus 1, typically a constant term, adding 1, subtracting 1, adding 3, subtracting 3, that's going to be a vertical translation, either up or down. All right, so as you progress through today, you can kind of start looking at what type of transformation it might be, but really what I want you to focus in on is what the parent function would be. So would it be a linear graph, quadratic graph, cubic graph, or square root graph? That's really essential is what we want to focus on today. So first problems here. Number 1, as I look at this, identifying parent functions, I see f of x equals x squared minus 5. So looking through this, I just want to have a base understanding of what type of graph this might be. Well, looking through here, I see I have an x squared term. That tells me right away I should have a quadratic graph. Now thinking about that quadratic, I know that it makes a parabola. So my graph would look something like that. And then again, to kind of step it up a little bit, thinking of transformations, I can look at that negative 5. Well, what type of translation that would make? That'd be down. That'd be a vertical translation, so that'd be down technically 5 units. So my graph would be shifted down 5 units. But again, if you understand that this is quadratic and it makes that type of graph, that's really what we want to focus on as much as we can today. Next one here, number 2. G of x, again, talked about that yesterday, you could have some g of x type functions. But g of x equals the square root of x plus 1. Again, I see this square root, should be evident. This is a square root function. Okay, so square root function. And then if we look back at our parent function, I see my square root function, typically it would go something like this. All right. Now we don't talk about quite the translations on a square root, a little more difficult. But if you think about it, a radical can never have a negative underneath of it. So, the lowest value you can have underneath there would be negative 1. Again, that would get me to negative 1 plus 1 was 0. So the square root is 0. So the lowest value I could have was x equals -1. My graph would actually start a little bit more left. But again, if that's a little confusing for you, don't worry. This is what you need to focus on right here, and that's the square root function. All right, number 3, h of x equals -2x plus 1. I see that I do not have an exponent for you, so that should hopefully tell you it's an invisible exponent of 1, which is our base function of a linear function. Now, a good review for Algebra 2, if you look here, and you see I have a -2. Okay, hopefully you see that -2, and that tells you I'm going to have actually a line going down to the right. Okay, that means I have a negative slope. A little review from Algebra 1 there, but a negative slope. And then the +1 would tell me that I have a vertical translation of a +1. Again, so all these different things tell me how I can transform functions, but really I just want to focus on what type of graph each one of these are going to get. Alright, these next 3, take a couple seconds here, press pause when you're ready, then press play, but give it a shot here, try some of these 3 on your own. Try and think about what type of graph each one would make. What's the parent function, and then maybe what type of shift it might have. Alright, let's go through number 4 here. If you look through it, you see this third power here. That should tell you that's a cubic graph. And have a look back at my parent functions. My cubic kind of follows a trend like that. If you look at the translations, might be a little more difficult here because there is parentheses. Some of you might have been confused. But even if you were to cube that out, that would still be a vertical translation of +1. Okay, even if you were to work that out, FOIL it, and then FOIL it again, little terms from Algebra 1 there, you'd still get a vertical translation of +1. Number 5, g of x equals -x squared plus 2. Notice the negative is not in parentheses. Big difference when you start plugging information in and doing the work. But hopefully you see that x squared term. I was going to tell you this is a quadratic. Now, if you thought it makes a u, you're correct. The key here is this negative actually tells me my u would go upside down. I actually get an upside down u here. Okay, and then if you look down here, my vertical translation, +2, it'd be a +2. Okay, and last but not least, number 6 here, I have -x, look at it, no exponent, which means it's an invisible 1. That tells me I have a linear function. And just like on the last slide, that negative out front tells me my line is going to be going down. It has a negative slope. Alright, next slide here. Last but not least, we're going to talk about identifying some parent functions. So if you're given some coordinates and you plot those coordinates, you want to see what type of graph that might make. So if you look here, they plot these points. I'm given the point 2, 0. So plot the point 2, 0, 1, 1, 3, 1, 0, 4, and 4, 4. Now looking up there, you kind of see that it slowly goes up both directions. So I'm making almost like a U there. That would be a quadratic, so that would be a parabola type graph. So I know it's going to be the parent function of f of x equals x squared. Now looking at it, you might be able to tell, but yeah, it's a horizontal translation 2 units to the right, because the parent function starts at 0 there, and we did move 2 units right. If you get that, great, but I want you to really focus on this part right here. Understanding what type of graph those points would make. So let's look at number 7 here. I'm given some coordinates. I'm given x and y coordinates. So I take it out here and I plot my coordinates. So -2, 1. So I go over -2, up 1. -1, -2. 0, -3. 1, -2. And 2, 1. So as I look at my graph here, I know I'm kind of starting to go down, then I'm going back up on my graph. Hopefully that's an indicator right there that this is a parabola. So I would have a quadratic, which would, my parent function would be f of x equals x squared. Now looking at that, if you look at the translation again, parent function starts at 0. So the best description of how that moves, that would be a vertical translation down 3 units. Alright, so the transformation there would be a vertical translation down 3. But again, if you get this right here, that's the important part, is understanding what those parent functions look like. Next one here, take a couple seconds, try this one on your own. plot the points, look at what type of graph it makes, and then when you're ready, press play again. All right, hopefully you press pause. Now you're ready to go here, but you've plot the points, -2, 2, check how you did. -1, 1, 0, 0, 1, -1, 2, -2. Looking at that, I can pull out my line indicator here, and I see it actually goes straight through those points. This will give me a line function, or f of x equals, ooh, that's bad parentheses, f of x equals x. And again, that'd be a linear parent function. If you look at there, hopefully maybe you can tell some different things about this graph. There's no translations up or down, but it is technically a reflection where it would actually have a negative slope because it is coming down. It's not translated up or down, left or right, but it would have a negative slope. So if you look at our parent function, it would actually be f of x equals a negative x on something like that. So, little review for you there. Assignment time. Yeah, sorry, I am not here, but it is assignment time. Copy the problems down here. Being a generous guy, and I am not here. It is Friday, and we do have a football game tonight. Hopefully everybody goes. Good luck with football, guys. Sorry I'm not here to help cheer you on today, but I will give you the 3-point assignment, so you can thank me on Tuesday for that. But hopefully you guys got this. If not, feel free to send me an email. Send me a couple questions if you do have some. But really on these, all you have to do is go through and just kind of identify what the parent functions are. But again, those both will be due on Tuesday, yesterday's assignment and this one. All right, thank you very much.